Hey y'all, are y'all learning ReactJS? Do you want a fun project to add to your portfolio website? Today we're going to go over how to make the classic arcade game Snake. The concepts we're going to cover are going to be the context API in React. We're going to go over some React hooks and also the reducer pattern. So if that sounds fun to you or you want to just check it out, watch this video. Also, if you have any questions about this project, if something didn't work out for you, or if you're stuck on one of your personal projects and you can't figure out how to get past that bug, go ahead and stop by on Thursday nights. I'll be streaming 9 p.m. Eastern here on YouTube. Come by, check it out. We'll see if we can help you out and see if we can get you unstuck. Be sure to follow me on Twitter to make sure that that streaming time stays up to date. Without further ado, let's go ahead and jump into the video. All right, so what you're gonna wanna do first is jump into the terminal and type in create React app, the name of the directory that you want your Snake game to go into. Then we're going to use a template I created to get us started and kind of do a lot of the boilerplate stuff. And that is CRA Template Basic Games, basic game singular. So once you get that done, you press enter. We'll fast forward through this. Almost done. Here we go. All right, so after that's finished, we can go ahead and cd into our Snake game directory, and we can run yarn start to get the game started. And that should fire up a new tab, go into localhost 3000, and then you'll see we have a little boilerplate of everything that we need. So you've just got a little title bar up here. We're gonna display the score here. We're gonna have our little play button, and this is where our Snake grid is gonna go. So let's go ahead and jump into our directory. Let's open it up in VS Code and see what the template gave us. With Create React App, you can always start in the app.js. If we go there, we can see we've imported a couple of things. Looks like we have a game context, and we have some state. Okay, we'll take a look at those in a little bit. So yeah, so we have the header. The header component's pretty boilerplate. It was extracted out because we're going to be displaying the score later. So we'll need to be able to reach into our game context state. We'll get to that here in a little bit. And then we have the game over banner. This is just displaying a game over div if the status of our game state is ended. We can get started with the game context component. So let's go ahead and open that up. Game context. Cool. Okay, so in here is the brains of our application, and we'll just start from the top and we'll work our way down. First thing to note here is we're creating two contexts, and that's a React context API. So if we just go quickly over to the documentation, we can see that the context API provides a way to pass data through the component tree without having to pass props down manually at each level. So it's really nice if you have a super nested tree and you want a prop to go from the top parent all the way down to the bottom leg of the tree. And that's pretty much it. The core concepts of it is you create it, it can pass down state, and you essentially have a provider and you have a consumer. Since React hooks, the consumer has been transferred into use context, the use context hook. And essentially what this does is you have the context that comes out, you pass that into the use context hook, and it gives you the value for your context. So if we come down here, we can see that here's the provider I was talking about, and that just takes in a value prop. And that value prop is what's returned from the use context hook. Simple enough, right? First couple of things in our game context. We created two contexts, one for the state, one for the dispatch. More on those in a second. And then we created two consumers, the use context hook. And those are just convenience methods. We're exporting them so we can use them elsewhere in the project. If we move further down inside of our game context component, takes in a couple of props, the reducer, initial state, and then the children get rendered out through it. So the reducer and the initial state props get passed into the use reducer function. The use reducer function returns a tuple, the first element being the state, the second element being the dispatch. So this is the reducer pattern I was talking about earlier. Essentially, the reducer pattern boils down to You have your state that you're displaying. That's that first element from the tuple. The second element returned from the tuple is the dispatch. Dispatch will send an action. That action is a object with a type property that tells you what type of action has been created, whether it's like on a click event, you send a certain action, or if you get data back from an API and you send that action, then you'll usually have a payload attribute. There's nothing stopping you from creating other attributes, but that's the most common pattern. That action or that object with the type attribute on it gets sent into kind of a funnel, which is the reducer. And most of the time, this is a case statement that checks the action type, goes through a list of functions to handle. Once it finds the correct one, it creates a new version of state and it spits that out. React does its thing. It does a diff of the DOM, changes what needs to be changed. We'll dive into that a little bit more later once we dispatching specific actions. So you can see an example of dispatching an action just below this. We have the on key press. And so this on key press here being used down below, and we're adding an event listener for all key down events. Every time you press a key on the keyboard, this action is going to be dispatched and it will send out an action with the type of key press, and the payload is going to be the key code. So which key has been pressed. Next up, we have useInterval. So when I first started creating this project, I tried to just use JavaScript's built-in set interval function, which has a callback and a time, right? And this did not work. Yeah, if you want to see what happens, go ahead and replace useInterval with set interval. It jumps all around the interval, goes haywire. It'll go from 1 to 10 to 20 to 120. If you really want to know more about that, you can come to Dan Abramov's blog post about it, and he goes through why it doesn't work and why it's unintuitive. I'll leave a link to that down below in the description. So our useInterval function takes a callback like set interval. It also takes the interval at which we want to run that function, the callback function. I added a third option into useInterval, and that is it checks to make sure that the status of our game is on or running. Yeah, so then we've already went over the use effect for adding the event listeners. So other than that, our game context just returns the two providers, the one for the state, one for the dispatch. The reason I did that was convenience. You could pile both of them into an object, into one single context value, but then you'd have to destructure state and dispatch every time. And that's fine, but I find it a lot easier just to go ahead and split it out into two different contexts. Now let's hop over to our state file, and this will be the last one that we need to really run through before we can actually start making some changes to our game. And this has our initial state, so that gets passed into our game context. And initially you just have status and the interval. Then we have a reducer. The reducer takes two arguments. It's the current state of the application. The second argument is the action, so what's dispatched over into the reducer. You can see what I was talking about earlier about the switch statement. It just checks the action type, and then it runs through. If the action type is start, do this. If the action type is resume, change the state to this. And we have two cases down here, tick and key press. Those are going to be the ones we modify going forward to make our snake game. So let's go ahead and hop over to the app.js. And if we go into there, we want to replace this board down here with a grid. Remember the arcade snake game? It kind of has a grid of squares, kind of like a chessboard or a checkered board. So let's get started with that. So with this, let's kind of start. It has a grid. We want to create a row. Each row is going to be made up of cells, and those cells are going to change color or be painted depending on the coordinates of our snake or our food or our apple later on. So let's go ahead and start with a cell. We'll create a cell component. And just gonna do a little function component. So we said that we're gonna paint the cell, and depending on the coordinates of the cell, and if it matches one of the coordinates in our snake or the apple state. So the cell needs to know what its coordinates is. Coordinates, cool. And for now, all we have to do is return a div. We'll just call that cell. Cool. Okay, so that's the cell, and the cell is going to be inside of the row component. So let's go ahead and make a row. So each row is going to be created of X number of cells. It's just going to iterate over a certain number and generate cells. So let's see. Let's see. So we're going to have essentially a div. It's going to have a class name of row. Okay, so in each row, we want to generate a certain number of cells. We can do that in JavaScript by, so in JSX, we have to do these little curly brackets when we want to run JavaScript. And then we'll just say, generate an array from a certain dimension. So let's just say we're gonna do 25 for how many cells we want to create. And then we're going to map over those. We don't care about the number, which is the first argument for the function, but we are going to have the X index as the second one. Okay, and that's just going to be a cell. In React, every time you iterate through things in JSX, you have to give it a key property. We'll just give that of the X index. And then the coordinate of the properties we want to pass in, and we're just going to have that be a tuple. We're going to have X index and then Y index. The Y index is going to be for the row. So let's do the same thing we did for the cell, and we'll add that as a property. We'll say X or Y index. So that gets passed in there. Looks like don't have enough closing brackets. Cool. So now Prettier saved everything for us and formatted it. So now we know that our code is correct. Next part, we'll call this our grid. So we're going to create a grid. Our grid component is essentially going to just be the same thing as our row up here. So I'm gonna go ahead and copy that, come in and paste it. We're going to have a map. We're going to iterate over that. This is going to be our Y index now, right? Because we're going to create rows. We're going to change this to Y, and then Y index, change the cell to row, and change this to Y index. I think that is essentially our grid. Next thing we need to do is come down and add our grid to our app.js component. We'll put it under the game over banner. Now we can come back to our browser and see what we have, and we don't have anything. Is that true? We can inspect, go into our board. Oh, it looks like we have rows. We have all the rows. Looks like we have a bunch of cells, but there's no styling on the cells. Okay, so let's open up our app CSS. We can go down to the bottom and add a row. Let's go ahead and add display flex. And what this is going to do is space all of the divs out inside the row. So inside of our row, our divs are cells. It's going to space those out equally in a row, kind of like the class name there. Then we're going to have a cell. Let's go ahead and give them a width of 1 EM, and we'll give them a height of 1 EM. We'll do a border, 1 pixel. Let's just do solid red. We can add some margin around them, just a little bit, just to space them out. And before we go back, we're gonna go ahead and delete this board class. So we come back to our browser, we'll refresh. This is what it looks like. Looks a little weird. And I'm pretty sure that is because of this board class in our CSS is set to a specific height. And so what we can do is just go ahead and remove that. Now we come back. Now we have our grid. Boom. This would be a great time to go ahead and commit. We can do that over here. we'll just go ahead and add all the changes, and we'll call this grid, and boom, we're good. Now that we have that, we want to generate our snake. I think that's the next step. So in order to do that, the snake is going to be part of our state.js. So we'll come back over here to our state file. We'll go into this and call it snake. And if we think about our snake, it's going to be an array of coordinates, right? So an array of X and Y coordinates. Let's go ahead and make an array. And then inside of that, we'll make another array. We'll do first cell, if you would. So the first coordinate. Now that we have our snake, let's go back to our app.js. And inside of our app.js, we are going to, let's take this state over here, and we'll split screen it over here. So what we want to do is change the class name of our cell if the snake coordinates match. So we have the coordinates coming in as a property for the cell. So what we can do is we'll just go into here, we'll pull out, we'll destructure snake from our use game state book. And so if you remember, that returns the state of our application, which is essentially the same thing as this initial state over here. And we just added snake to it. So initially we're going to have snake. We can destructure that property off of the object. And now all we have to do is say if any snake segment contains the same coordinates as the properties being passed in. So our snake is an array. So we'll just do snake.find. We can destructure the segment into X and Y, right? We just have to add the parentheses there. And then we just want to say, hey, if X is equal to coordinates 0, which is the X coordinates from the coordinates being passed in, and Y is equal to coordinates 1. So if that is the case, so we want to add to the class name. Go ahead and say class names equals cell, and we'll say class names dot push snake if the coordinates match up, if we find any coordinate that matches. And then the editor is saying something's wrong. It looks like we need an extra parentheses. There we go. Now the syntax highlighting came back and we're good to go. So then down here in the class name, we will just do some curly brackets because we want to write some JavaScript. And we'll just say class names, join, and we'll join them with a space. Boom. All right, so if we hop back into the browser, we can see we have no snake. So the first cell in our application is this one up here. So we can take a look. Oh, okay. So it does have the snake class on it. So that's great. So all we have to do is go into our app CSS. Let's go down into cell. So we'll say cell.snake, and we'll just say background color, and we'll just make it black. Refresh, and we have our first snake colored. All right. So next up, we're going to give this play button over here some actual action. So if we do now, nothing happens. Nothing happens on click. So we'll go ahead and add that. But first, let's commit. You can take a look at the changes. You want to make sure they're the right ones, or you can just take my word for it. Commit all. And for this one, we'll say paint snake. Hide that again. Our button is play here. And if we bring up our state, JavaScript on this side, we can kind of see what we want to do. So we want to dispatch an action. So let's go ahead and grab dispatch. So we'll say dispatch equals use game dispatch. If you're using VS Code, it should give you some auto completion. If you tab it, you can see it auto imports it up here. So we'll just call our hook, and we'll just go ahead and say handle click. Make this a function, and inside of there we'll say dispatch, and then we're going to dispatch an action. That's going to be a type. We'll come back to that. We don't need a payload, So all we need is the action. And boom. Oops, looks like I misspelled dispatch. Fix that. Now in React, to add an onClick event, all you have to do is come down to the button. You can see VS Code is auto-completing it for us. It's onClick. And we'll just say boom, boom, curly brackets, because we want to create or use JavaScript inside of JSX. And we'll just say handle click. The action type we want is definitely not foo. So let's go ahead and figure out. So if it's play, we want it to maybe say pause like this over here. We want to use that action. What we're going to do is, based on the status of the current state, we are going to display a specific thing up top. So let's go ahead and we'll create a map. So we'll say status map. And it'll just be a constant. We'll create a little object. And so if the status is new, we want the action to be start. Another time that we want to use the start action is on game over. So we'll say if the status is game over, we will send start as our action. Okay. If the status is on, we will want to send the action pause. And if the status is paused, we want to change to on. Does that make sense? So each key is the current status. The value is the action that we want to send to our reducer. We need to find out what the current state is. So we'll go ahead and get status. Current status from use game state. Then we want to just say status. Oops. Curly brackets because we want to use JavaScript, status map, and then we're just going to put in the current status. And we're going to do the exact same thing here, status map and status. Okay, so that should work properly. So I'll go ahead and save that. We'll jump back over to our application. Refresh if you have to. So we're back in the browser. We click start. Now it changes to pause. We've got a warning down here that says the tick method hasn't been implemented. If we pause it, now it changes to on. But if we click again, it doesn't work. Okay. Maybe we go back. So if it's on, let's click to pause. If it's paused. No. Yeah. We don't have. So if you look at this is the action type that gets sent into our reducer. We don't have an on case. So what we could do is create an on case, or we can use this resume here. So let's just say that resume. Now if we go back to the browser, we got start, pause, resume, boom, pause. Cool. Now that we have that done, we can come over to the state into the reducer, and we want to implement the tick, right? So if we go back to our game context, we can see when the status is on. So when you click start, resume, the interval will start happening and it'll dispatch the tick action. And we want to go ahead and handle that. So looking into the future, I think it'll make sense to have this as a separate function. So we'll just go up here. So we want to move our snake. And so let's say it takes in the entirety of the state. We're going to say state.snake. We'll save that as a constant. We're going to state.snake, and we're going to create a new snake. So it's going to be a segment. So each segment of the snake. And then we're going to want to move each segment. So let's go ahead and we'll call it another function. So move snake segment. We'll pass in the segment. And we also want to pass in the state.direction. And so then the move snake function, we want to return a new set of state and call in the snake there. So let's go ahead and figure out our move snake segment function. So that's taken as a segment, so we can call this X and Y with destructuring, right? Because each segment is just a coordinate, and so we'll just destructure those into the X and Y. and this is going to be the direction. And so what we'll do is we'll do a switch statement. We'll do it based on the direction. And then if it's up, we'll do one thing. The default will be just to return X and Y. And we have 4 directions. So up, down, right, left. Okay. In the up direction. So if we go to our browser, and we can look at our rows here. And so you can see as we go down, you can see I'm highlighting. As we go down, the Y index, or the key here, is going up. So if we want to go up, so from this row to this row, then we have to subtract 1 from the Y coordinate, right? Pretty simple. So X doesn't change, it's subtracted. Now that's the reason we have to subtract. It's kind of counterintuitive, right? Up, usually you add to it, but we're actually subtracting here just because of the way our page is rendered. So for down, it'll be the opposite of that. And then to move right, now let's just go back to the DOM and we'll open up one of these rows and we'll look the cells. So if we're going right, it looks like the key or the X index is increasing. So this one will be pretty intuitive. You just add 1 when you're going right and you will subtract it while you're going left. Looks like I forgot a parentheses right here, so we'll add that and save. Forgot a whole bunch of stuff. There's the curly bracket forgot there. And now all we have to do is come down here to tick and say move snake, pass in the state, and we can delete this console and the other return. So now if we come here, refresh our page, if we press start, hopefully it starts ticking. Started ticking, but nothing is happening, right? So you can see this number down here, it goes up, so we're getting a tick every time. Okay, let's go here. So why would the tick not actually change anything? So does our state have, our state doesn't have a direction. So we come up here, we add a direction, and we'll just say, we'll move the snake to the right. We'll just say right, come back over here, and if we click start, now we can see our snake is moving. Awesome. Let's go ahead and commit this, and then we can move on to, ending the game. If we watch this, if we watch him tick across here, usually in a game of Snake, there's a boundary around the grid, but in our case, there's not really. So what we want to do is once the snake's head goes outside of the grid, instead of doing this and just going off into nothingness, we want to end the game and show the game over. So let's go ahead and do that. Let's commit these, boom, boom, and we'll just call this start, stop, tick. Okay. So for the game over, there's a couple of things that we want to do. We want to find out, inside of here, we want to find out, hey, is our snake outside of the grid, right? So we start by thinking about that outside, I'll just say out of grid. And what we'll do is we'll pass in just a set of coordinates, which will be the head of the snake, right? We'll just say, hey, is X, it's X less than 0 or Y less than 0. Okay, so now we have the top. If it goes outside the top or goes outside the left boundary, we've got that covered. It'll return true and we are outside the grid. Next thing is X greater than, we have 25, right? Because right now we have 25 as our number of cells and number of rows. So what we're going to do is come over to the app.js 25, right? So let's go ahead and add export const dimensions. Add that as 25. We'll put that here and here. Okay, so now it's a const and we just have one spot to change it. And then over here, what we can do is go to our state. We can import dimensions, and then everywhere we have 25, right, in our row and in our grid, we can just change that to dimensions. Now all we have is one spot to change it and we're good to go. While we're moving our snake, what we'll do is we'll say if out of grid, and we'll pass in snake, this new snake that we've created, and we'll just pass in the head of the snake, right? And boom. Okay. So if the head of the snake is outside the grid, we don't really have to move the snake, so we don't need to update the snake's state. But what we do want to do is update the status to, if we look up here, possible values, change it to ended. So now if the snake goes outside the grid, we'll change the status to ended and we'll be good to go. So come back, refresh the page. Cool. All right, so if we go back over here and we press start, now as the snake makes it all the way to the end, okay, we're getting close. Game over. Awesome. So it looks like now that we have game over, looks like we can't start again because game over isn't the current status. So what this is, we change it to ended. Okay. And now that should show up there. And ended. Okay. And that's how simple adding the grid boundary to it was and making the game be over once we get there. Cool. So let's go ahead and commit that. We'll drop this, commit this, grid boundary. I made some pretty good progress so far, but now we're going to add controls. If you remember, we have the game context and we added this on key press, and then we have on key press here, and we're passing in the code as the payload of the action. And then that's pretty much that. So let's just come in here, and what we'll do is we'll just use the arrow keys. We'll keep it super simple. So we'll say to direction, all right? And let's see if we have arrow up. We want it to be up. That's the code for it. So arrow down, we want it to be down. Arrow left, we want it to be left. And arrow, we want it to be right. So the great thing is because we extracted out the move snake into its own function, we can now just call that function here. So we'll say move snake again, right? Because that's what we want to do. Immediately move the snake. And what we'll do is we'll go ahead and make a new copy of the state, and we'll change the direction. We'll say key to direction, and we'll pass in the action.payload, right? Because that's the code that's being sent in, the key code. And what we'll do is we'll say or state.direction. What that's going to do for us is if the action.payload, the key code, is in this key to direction object, it'll return the value that's over there on the right. If not, we will just return the current state direction and then move the snake. Actually, I think we want to do something different, right? Because that means if you press spacebar, it just moves the snake. So you could just sit there and tap, press spacebar and move the snake. So how about we put a guard on it? We'll say if, okay, so we can do a little bit better. So what we can do is just say, let's say if action.payload includes arrow, right? So if it includes one of those, then we'll do something else. We'll just return state. Okay. So then, so here's what we can do. We can say, instead of doing it like this with the key to direction, what we can do now, we already said, hey, it includes the arrow. So if it includes arrow, then what we can do is say action.payload, replace arrow with nothing. Oh, you can't actually see this because my face is in the way, right? Aw. How is that? Is that better? Cool. All right, so like I was saying, action to payload, that replace arrow, we'll replace it with nothing. And then we'll say to uppercase to make it upcase. Then we can just get rid of this key to direction altogether. I think we should be good to go. Let's head back on over to the browser and see if that works. So now let's just go ahead and open up the console. Key press happens. Start. If I press down, hey, it goes down. That's right. It goes right, up, right, down, left, up. Let's see if we get a game over. Nice. Get a game over. Awesome. So that is pretty much everything we need to do with key press. Pretty simple. So let's just go ahead and save that. Controls. Cool. Next up, let's generate the apple. So when the game starts, we'll generate an apple. When the snake eats the apple, we'll generate a new one. And this could be more complicated than we're going to make it. Making sure that, hey, if you generate an apple where the snake exists, to go ahead and generate another one, like try a different spot on the board. But we're just going to keep it simple for now and hope that it never generates one on top of the snake. So what we can do is let's just say, so what is an apple? It is just a random coordinates, which is an X and a Y. So it's a pair of random numbers in between 0 and this dimension constant up here. So what we can do is just say random, what are we gonna call it? Let's say random number in, random number on, and this function is gonna just use JavaScript's math random. So if we do math.random, math.random gives us a number in between 0 and 1, it's a decimal. Then we'll take that and we'll multiply it by our dimension. Okay, so if we get 0.5 and multiply it by 25, that'll give us what, 12.5. And so then we'll have to make sure it's a grid coordinate, we'll just round it down or round it to the nearest integer. So to do that, we will go here, boom, 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 math.floor. Okay, so we've got a random number in a grid, const. Next, we'll just say random coordinate. So this is 2 of them. And this one's super simple. We'll just do random num in grid, random num in grid. So now, when we start, we will go up to our, well, right now we'll just say apple is equal to random coordinate. Whenever we click the start button, we'll generate the apple, it'll show up. Go up to our initial state, and we'll just say apple is equal to, let's just do an empty array. Okay. Let's come back over here and refresh the page. And then when we click start, hopefully we get an apple. Doesn't show up. Let's see. So if we look in here, we can look at our React components tree. Okay. So if we click start, we look at our context. So it did give us an apple at 13.5. But it's not showing up because we have to add the CSS and styles to it. So we go to our app.js, and inside of our app.js, we go down to the cell. Okay. So I've already have something that adds the snake class, and what we'll do is do pretty much the same thing. We'll say if, let's see, if something exists, we'll add apple, right? And so we have coordinates, so we'll pull the apple out. So if apple x equal to coordinates x and apple y is equal to coordinates y, then we'll add the snake class. We're kind of already doing the same thing multiple times. So what I'm thinking about doing is coming over to our state class and add another helper method, and we'll just say coordinates equal, and we'll say x0. We'll destructure the first tuple, x0 and x and y0. Next we'll do x1 and y1, and then we'll just say if x0 equals x1 and y0 equals y1. And let's export that const. And then over here, we can add those in. Coordinates equal. That'll auto import up at the top, and we'll just say apple and coordinates. Now we can refactor this a bit, and instead of destructuring here, we'll just call it the segment. Next, we can just say coordinates equal segment and coordinates. Cool. Okay. So it looks like I have some syntax error. Let's see, missing a parenthesis, missing another parenthesis, missing another parenthesis. I think I got it that time. So now we can go over to here, and if the cell has the apple class name, we'll just paint it red, and I think that should be it. And once the page refreshes, if we click start, now the apple should generate. And there we go, got an apple down there. Now we can go down to the apple, and if we cross it, it just goes right through. So that'll be up next, is eating the apple. Cool. Okay, so let's just go ahead and commit this. So we'll stage these changes, we'll stage these changes, and we'll say generate apple. We've generated an apple, and we can move around. So now we're just gonna eat the apple in the original game, when you eat the apple, your snake just gets one segment longer. So every time you eat an apple, it gets a little bit longer, a little bit longer. It makes the game a little bit harder as it progresses. So yeah, so to do this, that coordinates equal function is going to come in handy, because now we can just see if the head of the snake is equal to the apple. If it is, we will add a segment to the snake and create a new apple, and we'll be good to go. So let's go ahead and go over to our, let's see, where should we put this? I think we have the move snake function, so we can just go into here. So I think what we want to say is else if, we'll add something here. So we'll say coordinates equal. The two coordinates we want to check are the snake head and the state.apple. So if these two are the same, we want to generate a new apple, and that will be random coordinate. And then we want to add to our snake. So we've got the new apple with the random coordinates. And then we can just say return state snake equals, and we'll just generate a new one, snake and cats. We'll add the last segment of the original state snake to the new snake. Boom. And also we will add the new apple. Let's see how that works. Let's check it out. Cool, but now when we move the snake, this looks weird. I've been able to create a monster. All right, so our move snake, our move segment function was just moving all of them. It's iterating over all of it and moving it. But that's not how a snake moves, right? It kind of slithers. So what we really want to do is just calculate the new head, remove the tail. So let's go back to our move snake function and see if we can update this. All right, so we said we wanted to calculate the next head. What's that going to look like? We'll say next head equals move snake segment. And we'll just call this snake. That's moving the snake's head, or calculating where the next head is going to be. So now when we go outside the grid, we can just say next head, right? And this one is the snake's head as well. So next head. Okay. And then here, what we're going to do is, so if the next head is equal to the current apple, we're going to generate the new apple. Let's just move these. Move this one up here. And then so what we'll do is we'll say, so the next head, and then we'll just splat the previous snake inside of it, right? So this adds a segment to the snake, and then also keeps the snake kind of moving along, right? We can't do the same thing down here. Let's go ahead and delete this snake up here, because we know that's just wrong. So we can't just do the same thing here, right? Because the snake is just going to get bigger and bigger all the time. Okay, looks like I've made a boo-boo. Let's say boom, boom. Stay down. Yeah. So I think I've got it now. So now if I click start, do we have an error? So if we refresh, we see the snake doesn't appear to be moving. We check out our state and see if anything's happening here. Let's see, start. Okay. Okay, so stuff's getting added to the snake. So our next head is being calculated, but if we look at move snake segment, it's expecting a direction, which I forgot to add in. So state.direction. Now if we refresh, see, it just kind of moves and moves and moves. And one thing to do with this is we could just say snake copy. We don't want to mutate the original state, so we'll say state.snake. So now we made a new array with what the old snake array used to be. So snake copy.pop. So that pops the last segment off the end, and make copy that in there. So we'll save that. And we'll see what happens now. I'll click start. Okay. That's working. Close my console. Getting close, getting close, getting close. That looks better. Now we pretty much have the game. Go around, just keep eating apples until you run into it. We'll commit it. Let's see, eat apple and approve, move. Nice, looks pretty good. The last thing we really need to do is add some score and maybe change the interval as you eat apples and progress through the game. We'll make it a little bit faster. So let's go ahead and check that out. So let's add, go to your initial state and you add score. We'll start with 0. Then if you come into your app.js, we have the header component at the top. We're already bringing out status. So we'll just bring out score as well. Then in that score piece, let's just go ahead and say score and refresh. The score shows up as 0. Sweet. So when are we going to score? So we're going to score whenever we're in this if statement, right? So whenever we eat an apple, let's just go ahead and put a comment here. Eating the apple. We're going to take the score and we'll just say the new score is going to be state.score. So the original score, and we'll say plus 10, right? We give 10 points every time you eat an apple. And you know what, we'll do plus state.snake. So now when you first eat an apple, it'll be plus 11, then it'll be plus 12, 13. So you'll get more and more points as the game progresses. And let's go ahead and change the interval as well. Oops. And for this, what we'll do is we'll say state.interval minus 5. We're gonna make it speed up a little bit more kind of as you go. So we'll just multiply that times the old snake length. We'll save this, give a little refresh, go ahead and go into the React components. I had to refresh again, but I got it. Now if we look at this, we'll have the interval and the score. So we start, saw the state change. Now we have the apple down there, and we'll just go ahead and eat this apple. Boom. Okay, so now my score changed. You can see that up there. You can see the interval down here is going down little by little every time we eat another apple. Sweet. That pretty much solves everything for the game. That's where we're going to end this video. But for homework, if you did follow along, go ahead and see if you can fix this bug so we can go through ourselves. And it's fine. Let's add running into yourself as a game over state. So inside of your move snake, calculate the head, see if it's in the original snake. And if it is, game over. Other homeworks, you can prevent going backwards. Like right now, you can just completely go backwards. That'd be a cool one to add. Another thing to add would be handling multiple apples. So maybe add a hard mode to the game. And with that, you generate 2 apples. And then you could eat 1, replace that 1. That'd be a really cool feature to add. But that's pretty much it.